So, back in 2014, this paper called Deep Speech came out from Baidu Research, and it completely changed how we talk to our devices. Seriously. It wasn't just some small improvement, it was like they threw out the entire old playbook for speech recognition and started fresh. But, to really get why it was such a big deal, we gotta look at what the world was like before.
I mean, think about it for a second. Why was talking to computers so hard? For decades, just getting a machine to understand you in a perfectly quiet room was a huge challenge. But what about in the real world? In your car, at a busy coffee shop, with the TV blaring in the background? Forget about it. That was pure science fiction. The world is just noisy. And for the longest time, our tech just couldn't handle it.
All right, so let's take a little trip back in time to the old world of speech recognition, or ASR, from the early 2010s. This is what things looked like before deep speech. And honestly, it was a mess. Super complex and really, really fragile.
See, the old way wasn't one smart system. It was more like this clunky multi-step pipeline. Imagine an assembly line where every single station was built by hand by a different person. You have one part to chop up the audio, another to figure out the acoustics, then another part to look up phonemes, those are just the basic sounds in a language, and then a totally separate part to make sense of the grammar. The problem? If any one of these delicate steps got confused, the whole thing just fell apart. And guess what confused it? Pretty much any background noise.
And the authors of Deep Speech called this out directly. They talked about these laboriously engineered processing pipelines that just performed poorly in noisy places. That phrase, laboriously engineered, that's key. It means humans had to painstakingly design every single piece of that pipeline. The real problem wasn't just that the systems were bad, it was that the whole idea of how to build them was flawed from the start. Okay, so that brings us to the big idea, the revolution. The Deep Speech team looked at that fragile pipeline and didn't say, let's build a better part. No. They said, let's blow the whole thing up. And this was their truly radical question. What if you could just replace that entire complicated, brittle pipeline with one single powerful network? What if you could just feed audio in one end and get clean text out the other? No more separate steps, just one elegant end-to-end system. And here it is. This is basically what they built. So the network takes in the audio, represented as these cool-looking spectrograms, and it just crunches through a bunch of deep learning layers. Now, a really important piece in here is a recurrent neural network, an RNN. And all you need to know about that is that it's great with sequences. It has a kind of memory, so it understands context. It knows what came before. And the coolest part? The output isn't some complex phoneme. It's just the probability for each letter of the alphabet. The network literally learns the entire mapping from raw sound to text, all on its own. This idea, this is the whole game changer, end-to-end learning. It was a massive philosophical shift. We went from humans trying to hand design all these little intermediate steps to just building one big, powerful learning model. The model itself figures out everything it needs, the important audio features, the acoustic rules, even some of the language, just by looking at tons and tons of data. So having a great idea is one thing, but actually making it work is a whole other story. To pull this off, the Deep Speech team had two, let's call them secret ingredients, that made their end-to-end dream a reality, especially when it came to tackling that noisy, real-world audio.
Okay, ingredient number one, data. So the problem was, if you want a network to learn how to hear speech through noise, it needs to be trained on, well, a lot of noisy speech. But can you imagine trying to collect and label thousands of hours of audio from busy streets or loud restaurants? It would be crazy expensive and take forever. So their solution was just brilliant. They decided to make their own. They took clean recorded speech and just layered all sorts of different background noises on top of it. We're talking everything from crowd chatter to car engines. And by doing this, they could create a truly massive data set. We're talking about over 100,000 effective hours of training data. That scale is just insane, and it was absolutely crucial. That's what gave the network enough examples to finally learn how to pick out the important stuff, the actual speech, from all that background junk.
All right, secret ingredient number two, pure raw compute power. See, a model this huge, trained on that much data, it was a monster to train back in 2014. It It required a ton of computational muscle. So their solution was to build a super optimized system that could spread the work across a bunch of GPUs. They did something called data and model parallelism, which is basically a clever way of splitting up the training job, both the audio data and the network itself, so multiple processors could work on it at once. It was a serious piece of engineering.
Okay, so they had the elegant new idea, they had the mountains of data, and they had the computing power to put it all together. So the big question is, did it actually work? Well, the results weren't just a small step forward, they were a giant leap. And honestly, we're still feeling the impact of this paper today.
I mean, just look at these numbers. They speak for themselves. This table shows the word error rate, and lower is always better here, on some really tough, noisy audio. You've got the big players at the time, Apple, Bing, Google, and then you have DeepSpeech. It didn't just edge them out, it absolutely destroyed the competition. We're talking a 19% error rate compared to over 30% for Google and almost 44% for Apple. This was the proof. The end-to-end idea wasn't just a neat theory anymore, it was flat out better.
And really, this is the big takeaway. That whole philosophy, this end-to-end, super data-hungry approach that DeepSpeech pioneered, it's now the gold standard. It's how everyone does speech recognition. The entire field shifted from people carefully handcrafting systems to just feeding massive amounts of data to a big network and letting it learn. So yeah, every single time you talk to your phone, your smart speaker, or even your car, you are using the direct legacy of this one paper.
So this kind of leaves us with a really interesting question to chew on, right? The big trick in this paper was creating fake noise to teach the model how to be tough, how to be robust. So what if we took that same idea and applied it somewhere else? What if instead of synthesizing car noise, we synthesized emotion? Could we create fake examples of joy or frustration or sarcasm in a voice and use that to train an AI that doesn't just understand what we say, but how we feel when we say it?
And just a quick heads up, this is for entertainment purposes only.